During an earthquake, something even more mysterious than the tremor itself is happening in the skies above. Something that up until 2007 had never been filmed, but had been whispered about for centuries. Reports of peculiar lights appearing just before earthquakes, described as glowing orbs, lightning-like streaks, and even fire in the sky. The last thing you'd expect to see during an earthquake is strange flashes of light. Blink and you'd miss the silent, electric, luminous dancing in the sky just minutes before the ground begins to shake. A ghostly pre-show with a devastating finale. What could be causing this? How could the movement of entire continents deep below us create a dazzling light show in the skies above, lighting up the land for miles around? I'm James Stewart and you're watching Astrum Earth. This is the fascinating truth behind earthquake lights. A natural phenomenon so rare and unexplained, it defies science and fuels legends. What are they? Why do they appear? And could they be Earth's warning light before everything shakes apart? Perhaps the most alluring aspect of earthquake lights is just how rare they are. Indeed, they are so rare and so undocumented that there is still some doubt over their very existence. Not only does this make just seeing them a nearly impossible task, it makes articulating what they are even harder. Sometimes called earthquake lightning, earthquake lights can take many different shapes, forms, and colours. They may appear similar to ordinary lightning, a bolt of powerful colour lighting up the sky as if from nowhere. They may be a luminous band in the atmosphere, akin to polar aurora, filling the sky with dazzling beauty. Other times, they resemble glowing spheres floating mid-air, as if a crystal ball was levitating before your eyes. They may also look like small flames flickering in the sky, like an airborne log fire, or even larger flames emerging from the ground, as if cast down from the gods above. The reason earthquake lights are able to take on such a wide range of colours, shapes and forms is likely due to the way in which they're formed, and specifically what they pass through, but more on that later. There are a select few who have seen these lights in action, or at least claim to. Eyewitness accounts date back over 1,000 years, telling stories of dragons lighting up the sky, detailing yellow orbs floating eerily in the distance. And in one American state, they inspired an entire book series called Haunted Somerville. The story was created after reports from locals seeing a glowing orb throughout the 1960s on a nearby abandoned railroad. A video taken in China shortly before the 2008 Sichuan earthquake seems to even show them as luminous, brightly coloured clouds floating in the sky, as beautiful and whimsical as they are devastating and chilling. The debate amongst some geophysicists still rages on in some corners, continually questioning and debating whether any of the reports constitute hard, solid evidence for earthquake lights. Historical witness testimonies of the rare and little understood natural phenomenon were typically dismissed by scientists as hearsay, or fodder for UFO enthusiasts and other conspiracy theorists. After all, how do you go about trying to prove something that only very few people have seen firsthand? What are we really dealing with here? Do earthquake lights really exist? Or are they simply another chapter in a book of fiction? Can they be chalked down to hallucinations from overzealous witnesses wanting to make a name for themselves? Or has science got another surprise up its sleeve? To find the first tales of earthquake-like incidents, you have to go back over a millennium, back to ancient texts from China and Japan, which depict luminous phenomena preceding earthquakes, often perceived as omens or even supernatural events. Deep in rural China, around the year 373 AD, those texts describe terrified farmers running for their lives after seeing fire dragons lighting up the sky. The texts chronicle that these dragons appeared moments before a significant quake in the region and disappeared just as quickly, lighting up the farmland a vibrant, angry red. In this period of time, the connection between gods, spirits and other worlds was rife, and sightings like these would only have fanned the flames of terror of what these people were witnessing. At this time, they wouldn't have even understood why the ground itself was shaking, let alone why dragon-shaped lights lit up the skies above them at the same time. These visions were likely the final images some of these poor people ever saw, with the legends of their encounters passing on from generation to generation. On the other side of the world, similar whispers of mysterious lights were being heard in the temples of ancient Greece. An ancient Greek historian, Callisthenes of Olynthus, wrote of immense columns of flame that foretold the earthquake that destroyed the cities of Helike and Bora in 373 BC. So convinced were the Greeks that these lights were one of their gods lashing out, punishing the people on earth for something unseen, that they built sacred sites like temples as an offering of peace in a desperate attempt to stop such divine intervention from supernatural forces happening again. As the years have gone by and technology has evolved, we now know that those structures are built close to or nearby fault lines deep underground, the very place you might expect to see earthquake lights. As time went on, accounts of earthquake lights seemed to dry up. So extravagant were the tales that many simply refused to accept them, and they all but vanished from the record books. The invention of electric lighting in the 19th century only aided their demise. Any accounts akin to possible earthquake lights were often dismissed as being caused by damaged power lines or other electrical issues as the world got to grips with the new technology. Similarly, with the birth of modern scientific seismology and instrumental measurement around the same time, the bizarre lights dotted throughout ancient history just did not fit into the framework of the classical mechanics of which seismology was built at the time. Scientists were at a loss as to how to explain them, and so tended to dismiss them entirely. The phenomena nearly vanished from planet Earth entirely, until one day, something extraordinary happened. Dr. Kuribayashi was a dentist in the town of Matsushiro, Japan, and he enjoyed photography in his spare time. After finishing his workday on the 4th of December 1965, he headed out that evening to take pictures of the nature surrounding him for his collection, when he looked up and spotted something strange just before midnight. A luminous aurora, blue-white with a reddish tinge, drenched the night sky, stretching out nearly 8 kilometers in diameter. Unbeknownst to the rest of the world, and indeed to him, this dentist had just captured earthquake lights on camera for the very first time. This particular region, Nagona in central Japan, was subjected to frequent earthquakes from 1960 to 1967. In fact, frequent feels like an understatement, because there were 62,826 during this period. They were so common, people quickly got used to them. They became a way of life, like taking the rubbish out or walking the dog. The earthquakes came from Mount Minakami, which is located in the centre of Matsushiro town, and they are known collectively as the Matsushiro Swarm. But even this seemingly indisputable evidence was not enough. Prominent seismologists like Sunji Rikitaki suggested the images were fabrications, nothing more than a trick of the camera or even a faulty lens. The world, it seemed, wasn't ready to accept the existence of earthquake lights. Something had to give. On the other side of the Pacific Ocean, Jim Conitcher, a retired agricultural inspector, was out for his daily hike on Tagish Lake in Canada's Yukon Territory in 1973. Mid-hike, he looked up and was aghast to see what he thought were UFOs in the distance. He saw several yellow orbs, 1 meter in diameter, floating like an alien craft on a mountain, darting around as if choreographed to an invisible song played by an orchestra from another world. Quickly, he reached for his camera, and in doing so, captured one of the eeriest known earthquake light sightings to date. It's as if the camera itself has flared. There, right in amongst the mountain, a yellow hue peers out toward the lake, as if lighting an enticing path to a hidden land. Unbeknownst to Conitcher at the time, these mysterious orbs appeared just minutes before the nearby Cross Sound earthquake on the 1st of July 1973. The evidence for earthquake lights was finally starting to gather momentum. In Tangshan, China, residents were woken one night in 1976 by great fireballs lighting up the skies above, flashing in the darkness like a firework display. The next night, right on cue, an earthquake registering 7.8 on the Richter scale ravaged the area, tragically killing more than 250,000 people and destroying the entire city. The stories of the mysterious lights joined local lore, as locals tried to process what had just happened, and tried to piece together the hours that led up to the earthquake and the strange firework display so many had witnessed. The next time the elusive lights struck, they displayed a bright purple-pink, appearing as globes of light hovering the St. Lawrence River near Quebec City in Canada, 1988. As if by coincidence, these lights were observed in the days and weeks leading up to and during the Quebec earthquake, including foreshocks, the main shock, and even the aftershocks. The lights varied in appearance, with descriptions including globular masses, bands, rays, and intense atmospheric illuminations. In Pisco, Peru, an 8.0 magnitude earthquake struck in 2007 just before 7 p.m. But moments before the quake struck, something even more spooky was occurring. A naval officer saw pale blue columns of light bursting out of the water at least 4 times. Several similar lights were observed along the Peruvian coast and were extensively reported in the capital city of Lima, about 150 kilometers northwest of the epicenter. But this time, something changed. The entire event was caught on video. A random CCTV camera outside a mobile office captured flashes of bright blue, drenching the nighttime sky a dazzling shade of turquoise. By complete chance, a seismometer record had been set up at a nearby university campus, not far from where the footage had been captured, and finally, the dots were beginning to connect. The seismic activity record directly matched the qualified eyewitness observations and CCTV footage of the phenomena from other parts of the city. It had been confirmed. The lights appeared during that 8.0 earthquake. Now, for the first time really ever, there was unequivocal evidence that these peculiar lights did indeed directly correspond to earthquakes. From then on, things moved fast, Shortly before the 2009 earthquake in L'Aquila, Italy, flames of light several inches high were seen flickering above the stone-flagged streets of the town's historic centre. Many people reported peculiar sightings of glowing lights, flashes, lightning, flames, luminous orbs, and even giant fireballs, all of which were considered prime candidates for earthquake light. Overall, 241 luminous phenomena were documented. Things didn't stop there though, because this camera-shy event showed itself again in Wellington, New Zealand in 2016, turning the sky a stunning aquamarine. Just 1 year later, after an 8.1 magnitude earthquake struck off the southern coast of Mexico on the 7th of September, videos of fuzzy green smears in the night sky went viral online as the light struck again. As if trying to outdo itself with each earthquake that appeared around the world, the firework-like display returned as recently as 2023, flashing above the skies of Morocco, moments before a devastating earthquake struck the country. During the Morocco quake, the earthquake light seemed to take things to a new level, lighting up the entire city in the dead of night with its ominous white-bluish tinge. All of a sudden, earthquake lights had been thrust into the scientific spotlight after far too long in the dark. But one big question still remained unanswered. What freak of nature could possibly cause them? For this, we must turn to physics. As science has clamoured to make sense of this beautiful phenomenon, accompanied by terrifying consequences, a number of explanations have come to light. Pardon the pun. Actually, this might be a good time to tell you this. Before we get stuck into the physics of it all, I know for a lot of people, and especially me, the word physics still sends shivers down my spine. It's the subject I struggle the most with, and if you feel the same, well, I've got some good news. We've teamed up with Brilliant for this video, and they can turn anyone into a physics person, even me. Brilliant helps you excel in a range of subjects, with visual interactive problem solving and personalised practice. The cool thing is, it starts you at the right level based on your background. It designs practice sets and helps you advance at your ideal pace. So after you watch this video, maybe you feel the urge to dig a bit deeper into physics or maths or even computing. They have a number of courses available. I'm loving their scientific thinking course right now. It's helped me further build my own scientific intuition with lessons in physics, electricity, digital circuits, and more. To learn for free on Brilliant, go to brilliant.org/AstrumEarth. Scan the QR code on screen now or click the link in the video description. Brilliant's also given our viewers 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant, as we head back to the video. One of the most compelling theories stems from Yuji Enomoto, a Japanese seismologist at Shinzu University. In a paper published in July 2024, he proposed that earthquake lights could result from the chemical interactions of gases like radon and methane released from underground. The article proposes that earthquake lights are primarily caused by physiochemical changes in fault zones within the Earth's lithosphere, where deep Earth gases like the radon and methane I mentioned are present. These changes interact with the atmosphere, hydrosphere, and ionosphere, leading to those puzzling earthquake lights. So could an earth fart, to use a colloquial term, really be the cause of one of the greatest unexplained phenomena on planet Earth? Well, so in depth is this article that Enomoto breaks down 11 separate incidents of earthquake lights in Japan from 1965, explaining how his theory ties into each and every one. For example, in the Matsushiro swarm, which had a staggering amount of earthquakes over a relatively short period of time, the focus is on a small volcano called Mount Minakami, near Nagano in central Japan. When the volcano ceased to be active, the magma cooled down, leaving numerous microcracks in the surrounding crust. In that environment, high temperature, high pressure carbon dioxide bearing water was released from the cool magma reservoir deep underground, causing felt earthquakes. As the felt earthquakes continued, mysterious lights often appeared silently on Mount Minakami, illuminating the dark night sky and captured by our dentist friend, Dr. Kuribayashi. Animator proposed that this may have been caused through the crack fronts at the epicenter of the earthquake becoming negatively charged due to the interaction of fracturing rock with deep earth gas, inducing a positive charge on the ground surface through electrostatic induction. At the same time, the opposite is happening in the thunderclouds above, where the meteorological front tends to charge the ground surface negatively. This results in rapid fluctuations in the Earth's potential, competing with the electrical fluctuations from the underground interactions from the gas, potentially creating the earthquake lights. Whilst Animator's theory is widely accepted, the exact mechanism behind earthquake lights is still not fully agreed upon. Indeed, our inability to explain earthquake lights has been going on for so long that, understandably, because they're not always present during an earthquake, there are still, despite all those examples, those who question if they're even real. Thankfully, for the sake of this video at least, they are definitely real, according to John Durr, a retired geophysicist who used to work at the US Geological Survey. And there's another theory alongside Animator that offers us some clues. Perhaps the leading theory currently available proposes that piezoelectricity, a process where certain materials produce an electric charge when subjected to mechanical stress, is responsible for the lights. Friedman Freund, John Durr's collaborator and adjunct professor at San Jose University, and a former researcher at NASA Ames Research Center, based his findings not on the gases emitted, but rather around the rocks deep in the ground, and what the stress of an earthquake does to them. According to Freund, tectonic stresses preceding or during significant earthquakes cause defects or impurities in rock crystals to fracture, which consequently generates electricity. In other words, the rock is an insulator that, when mechanically stressed, becomes a semiconductor, an example of piezoelectricity. Durr and his colleagues gathered information on 65 American and European earthquakes associated with trustworthy reports of earthquake lights dating back to 1600. The researchers found that some 80% of the light occurrences studied were observed for earthquakes with magnitudes greater than 5.0, which corresponds to a medium-sized earthquake. In most cases, the phenomenon was observed shortly before or during the seismic event, and it was visible up to 600 kilometers from the quake epicenter. It's worth noting that from this particular study, the lights only seem to happen before or during an earthquake, not after, and we'll come to the reasons why shortly. They also found that the vast majority of earthquakes linked to earthquake lights occurred within tectonic plates, rather than at the boundaries or outside of them. To add further intrigue, the team found that 97% of earthquake lights were associated with subvertical faults, which only cause about 5% of the Earth's total seismic activity. Now, of those 5%, earthquake lights are only present in less than 0.5% of the quakes. Subvertical faults occur in regions where tectonic plates undergo extensional stress, leading to the formation of vertical fractures or rifts in the Earth's crusts. So, could this be a clue as to why they occur in the first place? Well, prior to earthquakes, huge volumes of rock, and I do mean huge volumes, hundreds of thousands of cubic kilometers worth in the Earth's crust are being stressed. All that stress causes the grains in the rocks to shift relative to each other. It's a bit like switching on a battery, generating electrical charges that can flow out of the stressed rocks into and through unstressed rocks. In an article he wrote for The Conversation in 2014, Freund said the charges travelled incredibly quickly, at up to 200 meters per second, and they travel far too, easily meters in lab experiments and up to tens of kilometers in the field. In the same piece, he describes the process of charges flowing through the Earth's crust, and as they do so, they emit ultra-low frequency electromagnetic waves. Once they reach the Earth's surface, they produce a range of secondary reactions. This includes infrared light, massive air ionization, and corona discharges, which in turn produce ozone and broadband radio noise. So, where do the lights come from? Well, producing earthquake lights requires special conditions, which we are only now slowly beginning to understand. Stress on metamorphic and igneous rocks likely generates mobile positive charge carriers, which in turn cause the earthquake lights we've observed over time. But for this to happen, there are a few things that need to be present. Firstly, the makeup of the rock itself must contain many peroxy bond defects. These are tiny glitches in the rock's atomic structure, where two oxygen atoms are joined in a way they wouldn't normally, under stable conditions. You'd find these defects in volcanic rocks, which contain crystals that can fracture under stress. Rock types like basalts and gabbros, which have tiny defects in their crystals, mean that when a seismic wave hits, electrical charges in the rocks may be released. This resulting positive charge, or hole, can then move freely through the rock. In some areas, basalts and gabbros are present in vertical structures called dikes, which formed as magma cooled along vertical faults and can reach as deep as 97 kilometers underground. These dikes may even funnel electric charges along the magma corridor, expediting the process further. The second condition is that those rocks must be stressed very quickly. Under these conditions, so much electrical charge can be generated that the rocks enter a rare physical state known as solid-state plasma. This basically means that although the rock is still solid, because it's solid, there are way more particles than something like gas, so you get more charge from a smaller volume. There's more bang for your buck. As a result, the tiny particles inside are moving super fast and acting wild like they would in plasma. At this point, when the positive or negative charge carrying particles generated by the rapid stressing of the rock reach a critical density, they can move through the rocks as plasma. Once this cloud of electrical charge reaches the Earth's surface, it can burst through and discharge into the air like a fireball of energy. And the result? The luminous earthquake lights. The visibility of the light and the infrared emissions that the positive charges on rock surfaces emit depend on the charge density and the surface topography. Ionization, resulting in visible light, is more probable over peaks and crags, for example. That's because these features have a larger surface area, leading to a thinner charge layer. A thinner layer with the same charge would create a stronger electric field, increasing the likelihood of electrical breakdown of the air. This would explain why there are more eyewitness reports of earthquake lights in mountain regions or areas of altitude. Interestingly, when lights appear prior to an earthquake, Robert Thérelot of Quebec's Ministry of Natural Resources and his colleagues believes this indicates a relation between the lights and the speed at which the stress deep underground builds up prior to a fault rupture. Whereas, when lights and earthquakes occur at the same time, the team believes the phenomenon is related to changes in stress that occur as transverse shear waves spread through the crust as the earthquake strikes. To imagine this effect, picture people in a line holding hands. They are the atoms in a solid. Now, if one person jumps up, they pull the next person up with them, and so on as it travels down the line like a wave. That is a transverse shear wave, and that's the thinking behind why earthquake lights occur during an earthquake, according at least to Thérelot. There are multiple, well thought out theories and countless pieces of evidence of earthquake lights. So why can scientists still not pin down a single satisfying explanation? Well, the answer is a pretty simple one. These phenomena are ultra rare, and so despite the evidence amassed over the decades, it's extremely hard to test any of these hypotheses in the field. The lights appear so disproportionately before or during earthquakes rather than afterwards, so you'd have to get very, very, very lucky to be in the right place at the right time with all the equipment ready to roll, and as such, the conditions are virtually impossible to replicate in a lab. But perhaps earthquake lights could have another purpose. Given that they occur during and prior to the earthquake striking, could they help predict an earthquake before it even strikes in the first place, like a multicoloured alarm system? Earthquake lights have popped up all around the planet, but the most documented cases have occurred in Italy, Greece, France, Germany, China, Japan, and parts of South America. It makes total sense in theory, right? If you live in a region prone to earthquakes and you see bright explainable lights in the sky, you may have some extra time to prepare for what's to come. The reality, however, is a little different. Despite our working knowledge of earthquake lights, neither the United States Geological Survey nor any other scientists have ever accurately predicted a major earthquake. But surely, if the sky lights up like a Christmas tree, this must be able to help in some way? Well, opinions are divided. While Freund is working with other scientists on a global earthquake forecasting system that includes earthquake lights as an indicator, Bruce Presgrave from the US Geological Survey's National Earthquake Information Center does not think earthquake lights are useful signs. He suggested that simply because of how incredibly rare they are, they cannot currently be a reliable predictor. Earthquake prediction is actually a pretty divisive conversation in itself. For more than a century, early warnings of earthquakes have remained a dream for seismologists. There are records of many different types of signals that the Earth seems to produce during the weeks, days, and hours leading up to a major seismic event. Yet, nobody has been able to read these signals or say how they may be connected. In better news, there have been instances where the spectacle has potentially saved lives. Just before Italy's L'Aquila earthquake in 2009, a man in his kitchen saw bright flashes of light. Having reportedly read about earthquake lights before, he took it upon himself to move his family to a safer place, thus avoiding much of the damage they would have otherwise been exposed to. Similarly, during an earthquake in China in 1976, a geologist took shelter after seeing earthquake lights, which were followed by the deadly Tangshan quake. While scientists clamour to explain the reasoning behind these intoxicatingly beautiful displays, earthquake lights, with their elusiveness and ethereal beauty, continue to captivate both scientists and the wider world. There are many prevailing theories, but it seems like the electrical impact on rocks, and indeed what's inside those rocks dotted around the world, that feels like the most plausible and the closest explanation as to what causes earthquake lights. Whether these luminous preludes may serve as harbingers of impending disaster or not, earthquake lights remind us of the awe-inspiring wonders and untamed mysteries that still exist within our world, waiting to be illuminated by the light of understanding. If you felt this video was worthy of a like, please hit that thumbs up button. It lets YouTube know that you like what we're doing. It massively helps the channel and hopefully means more people get to see our content. Thank you so much and see you in the next one.